Hello everyone, I'm Sanggan Kim, a PhD student of Texas A&M University. In this video, I'm going to talk about the code and write-back stages of y8664 sequential processor. Let's get started. Okay, here we have a diagram of the code and write-back stage over here, and then we have a register table, ID table over here. And actually, in the decode stage, it reads data from register file, and the write back stage writes data to the register. But timing of each stage are different. So decode stage will start whenever input data is available. So actually source A and source B are ready, then it will output. Because reading should be fine even with some unavailable input, right? So it won't halt our the implementation or register values just because it is reading in the decoding stage. So it is okay to start as soon as input comes. And then for write back stage, it should start after memory stage, because one of the input data this write back stage will write is from the memory stage. So here the val m is the output of memory. So since we want to write the val m to a certain register when it is ready, otherwise we will mess up or corrupt the one register value. Okay. For read, it has two ports for input, two ports for input, two ports for output. So input ports for read are source A and source B. Okay, and then our ports for source A is val A, and our port for source B is val B. The for write, it has actually 4 input ports and 2 input ports for register ID, destination E, which is register ID for writing value E, and next input port is destination M, which is the register ID for value M here. Okay, again register ID for the test E is register ID for value E coming from the ALU, and then test M is the register ID for writing the val M coming from the memory. Okay, but the actual register IDs are selected by instruction code or I code. And if the fetched instruction does not have to read or write registers, then it selects F. So this in front of 4 input ports, test E, test M, source A, and source B, it has a control logic that selects the correct ID register IDs. So based on the instruction code. So for example, let's say we are fetching one instruction. We fetched one instruction, and one that does not need to read RA. Then even though we put this RA value, then the source A will output 0xF because we don't have to read. And again, if we need to, if the current instruction need to read the value of RB, then it will be output ID of RB. And same for dest E and dest M. Okay. Okay, here we have two tables on this slide, and the table on the left, I believe you are familiar with it because I recommended you to transform the tables about computations for each instructions with all the stages, but that is not very useful. So we want to have all the combinations for one or couple of stages with all the instructions. So that's why we have a table on the left hand side, but this is good for human like us to see all the computations. But to generate our all control circuit or control logic to select input to the register file over here, so we need another form of table to design these gray boxes, control logics. Okay, so then for each box associated with one column in this table, source A, source B, dest E, and dest M, and it has all possible outputs. Like in the case of source A, it can output RA or value of register, ID of RSP, or like 0F value, which means no register read. And then for source B, it could output RB, ID of register, RSP register, or just 0XF, no register read or write. And the similar with dest E and dest M. And how I get this, all the possible outputs, it is all from the computations for all the instructions. When you understand all these computations of decode and write back stages for all the instructions, then you can come up with list of possible outputs for each control logic. Okay, and then so for example, for RM move Q and MR move Q as an example, we have computations for decode and write back stage. And then let's try to write so outputs of this four control logic using these two instructions. So for RM move Q instruction, since in the decoding stage, since we need to read value of RA over here, we need to output ID of register RA value. And then and also we need to read RB value, register of RB, which is base address, that where we need to write in the memory. So we also need to read register value RB, not register of ID of RSP or just 0XF, which means we don't read or write register. Okay, and then in the write back stage, we are not going to write anything to the register file here. So we just put or output 0XF. Okay, so just for RM Q, move Q for now. So we output F value for destination E. Okay. For the same reason, we output F for dest M. Okay. Then we are done for register. Instruction RM move Q. And then for MR move Q instruction, so since we just need to read value of register B, value of RB, register the value of register RB. So we output RB, but since we don't need to read RA, we just output F. And then for the write back stage, we are not going to write value E to the register file. So we put F for dest E. But we are going to write value M to the register RA. So we need to output RA. Okay, so with this way, you can fill out whole this table, and then based on this table, you can easily implement these 4 control modules. Okay, so this part, one column, will be used for one control logic. Okay, let's talk about implementation of register file inside a register file module. So I took this figure from the Fahid book, figure 4.78 in page 226. It has registers, list of registers, but since it is 4x32 register file, so it has 4 registers. But same way, it has in 2 input ports to read. It has just 1 input port for read, so read address, and then this is the output of the register we just read. And then it has a 1 data to write, and then this is the register ID to write this data. Again, it has only 1 port for write. But you can refer to this the diagram to extend the input and output ports and with more registers. Okay, so I believe you already studied this register file in detail with Dr. Kim in the lecture, so I will skip the talking about details. Okay, but I want to mention that you can refer to this simple design for our own register file. Okay, this is it for decode and write back stage, and in the next video I'm going to demonstrate the y86 processor with fetch and decode write back stages. Okay, thank you.